गुड मॉर्निंग भैया, सॉरी गुड आफ्टरनून. गुड आफ्टरनून भाई. वॉइस वस्तुंदा. चेक वंस. ऑडियो वीडियो क्लियर. Check, 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 check. Audio and videos are clear. Good afternoon, bhai. Good afternoon, good afternoon, good afternoon. Good afternoon. So, how is the life going? Chilling, grilling, drilling. Good afternoon, bhaiya. Chilling. Revise something. Did you revise something? Badhiya. So last class what I taught you, let's have a quick viva on that. I said this was the cathode ray tube, metals are connected to the high voltage, 10 to the power 5 volt, 1 lakh volt roughly. Here this was the negative terminal, cathode we called it, positive terminal, anode we called it. From here the electron jump out and they start moving towards anode. First question, are the electrons visible? Twarga twarga, yes or no? Electrons are visible, yes or no? No. Then how do you observe electron? How do you observe the cathode rays? How do you observe the cathode rays? Bilkul, by a fluorescent or phosphorescent material like zinc sulfide. Perfect. And we are coating zinc sulfide just behind anode here. So electrons were rushing towards anode. They strike the back of the anode because momentum is there, it will keep going ahead. It will not stop here. It's like a race. When people are racing, they will not stop at the end point. Because of momentum of their body, they go ahead. So they went ahead, they struck here. And there you got the glow on the fluorescent or phosphorescent material. That's how you observe the electrons. This stream of electron, this current of electron is called cathode rays. Correct, bhai? Cathode ray particle properties are dependent on the nature of gas or independent of the nature of gas. Dependent on the nature of gas or independent of the nature of gas. Cathode ray particle property. Independent. Why? What's the reason? Independent. What's the reason? Any gas I keep, I will get the similar kind of cathode ray particle. Why? What's the reason for it? Cathode ray particles are dash. Intelligent idiots. What are cathode ray particles? Fundamental, basic constituent of all atoms. Basic constituent of all the atoms, fundamental particle of all the atoms. So any atom you take, any gas you take, the electron would be same. Up to here we have studied. Now today what we have to start. Shall we start now? Can we start today? Ready? We have to start this, that why have we taken low pressure 10 to the power minus 5 atm? Why have we taken low pressure? Understand now. Electrons are going towards anode. And let us say, in the last class did I say to move your hand like this? Perfect. So for less collisions, we need low pressure. So up to here we have completed. Did I explain you anode ray particles also? Did I explain? Because in my memory, anode ray particles I have not explained you. I have just given collisions are less. Sums I have given, that was charge to mass ratio. Now from here we are starting the story. We have low pressure, less gases are there. What are these? What are these circles? These are gases. So now what will happen? High energy electron will come here, will strike the gas. From this gas, another electron will be ejected. Why, sir? If someone slap you tightly on the face, so teeth will come out. someone slap you tightly on the face, teeth will come out or brain will come out? यार ऐसे यार त्वरगा imaginary situation, someone came and tightly slapped on your face, not studying properly, not doing the homework. So teeth will come out first or brain? Why teeth? So because teeth are outside, easy to release. In the same manner, in the atom, proton and neutron are inside the nucleus. Electrons are revolving around it. So when someone will slap the atom, what will be ejected first? Electrons. So electron, full energy electron came, he slapped this gas with full energy. So what came out of gas? Electron. Here also tight slap, electron ejected. Now electron is negatively charged. If I am the gas and from me electron came out, what charge would I have now? After removing electron, after removing one negative charge, what charge would I be left with? Positive. This positive charge will be left. And these gaseous cations, they are called anode ray or canal ray particle. And because they are positive, they will start running towards negative terminal. So the anode rays are moving towards cathode. So if someone asks you, what are anode ray particle? Twarga, try to reply, let's see. And don't make up any answer. Don't create answer. Whatever I taught you from there only answer, don't give innovative answer. What are anode ray particle? A Nani. Oh Nani. You really think someone will see your message here and they'll be impressed with, wow, Nani messaged me. Oh my God. Oh uncle, you are not that Nani. You are some local Nani. There are thousands of Nanis like you. And Lavanya don't care. She care about anode ray. Hanji bhaiya. Perfect. So what are anode ray particle? So anode ray particles are protons. Bilkul bakwas, bilkul garbage. One person have said hydrogen, very stupid. If you are saying anode ray particles are, what I just now taught you, anode ray particles are gaseous cation. Perfect answer. So anode ray particles are gaseous cation. They are not protons. They are gaseous cation. Cathode ray particles are electrons. But anode ray particles are gaseous cation. Twarga say cathode rays. Cathode, yes, last class. Cathode rays originate from where? Starts from where? Cathode rays originate from where? Cathode ray starts from where? Cathode. Anode ray starts from anode. True or false? Anode rays start from anode. True or false? What do you think about it? Anode rays start from anode. Bilkul bakwas. Anode ikkada. Anode rays are starting somewhere in the middle. In the middle of the canal. Canal rays. In the middle of the canal due to collision. So anode rays do not start from anode. Cathode rays start from anode. Sorry, cathode rays start from cathode. Anode ray do not start from anode. Cathode rays are electrons. Cathode ray particles are electrons. Anode ray particles are not protons. They are gaseous cation. Up to here, any problem, any samasya, any pida, or shall I move on? Twarga, say. Can I move on to the next page? Badhiya. Great. So let's take the example. I'm taking some gases in the cathode ray tube. Let's say O2, N2, H2. Three different gases I have taken in the cathode ray tube. And these gases, what anode ray particle they can generate or particles they can generate. Let's see. So if the gas is oxygen, I will be able to get O plus. Chala energy electron came, broken down O2, electron also ejected O plus. Nitrogen N plus, hydrogen H plus. Gaseous cations. Clear, bhai? O2 plus also possible. For simplicity, I am taking this. O2 molecule, one electron can eject from there also. But for simplicity, just for simplicity, I am taking O plus, N plus, H plus. So do you agree that different gases will have different anode ray particle? Twarga say bhai. Anode ray particles are gaseous cation. So different gas, different cations. So bhai, mass and charge to mass ratio of anode ray particle depends on nature of gas. Agreed. Cathode ray particle, every time electron. Any gas you take, same cathode ray particle will come. But anode ray particle will be different for different gases. Clear, bhai? Can you compare charge to mass ratio of O plus, N plus and H plus? Who is the maximum? Let's compare charge to mass ratio. O plus. O plus means plus 1 E. Plus 1 charge plus 1 E. Mass of oxygen atom 16 AMU. Plus 1 E. Nitrogen 14 AMU. Plus 1 E. Hydrogen 1 AMU. Are you aware? Hydrogen mass is 1 AMU. Nitrogen 14 AMU. Oxygen 16 AMU. So plus 1 by 16 plus 1 by 14 plus 1 E, and plus also not required because we only take magnitude. Remember last class I taught you specific charge, we only take magnitude of the charge. So 1 is more or 1 by 14 is more or 1 by 16 is more. Units are same, E by AMU. Which is maximum, 1 or 1 by 14 or 1 by 16? So sir, 1 maximum. Tarvata 1 by 14. Tarvata 1 by 16. So whose specific charge is maximum, bhai? Who will be deflected more in the external field? Remember, deflection in external field is proportional to Q by M. So who will be more deflected in the external field? H plus. Tell me, which is the lightest anode ray particle here? Lightest anode ray particle, smallest anode ray particle, lightest anode ray particle. So the lightest, the smallest, the cutest, the sweetest anode ray particle, the smallest and the lightest anode ray particle. Who is that? H plus. And this bhai sahab is Sakshat proton Dev. Remember, proton is H plus. So proton is the lightest anode ray particle. Anode ray particles are not protons, but there is one anode ray particle who is proton. Who is that anode ray particle? H plus. Clear, bhai? So my question is, what should be the gas in the cathode ray tube? What should be the gas inside the cathode ray tube to generate proton as the anode ray particle? What should be the gas in the CRT to generate proton as gas in cathode ray tube to get proton as anode ray particle? Answer is Hydrogen gas. If hydrogen will be there, then only H plus will come na bhai. So understand the English here. Anode ray particles are protons. No, this is not proton. This is not proton. This is not proton. Anode ray particles are not proton. Anode ray particle can be proton if you take hydrogen gas in the tube. But cathode ray particle is always electron, whichever gas you take in the tube. Cathode ray particle is always electron, but anode ray particle is not always proton. In fact, it is proton in only one example, that is H plus. This much clear or not clear, bhai? Twarga, twarga, chapandi. Badhiya. One example I am taking, assuming that you might have noted down this. One example I am taking, we take helium gas. In the cathode ray tube, I have taken helium gas. Ab yaar, helium gas, it can form He plus by releasing one electron. It can form He2 plus by releasing two electrons. Helium has only two electrons. Helium atom have only two electrons, so he can form only +1 and +2. Tell me, can I say that some anode ray particles can have multiple of fundamental positive charge? Say bhai, I am saying cathode ray particle, cathode, day before yesterday class, last class, it will always be -1e, always be -1e. But do you agree that anode ray particle can be +ne? It can be 1e, 2e, 3e, depending upon how tightly collision happened. Twarga say clear or not clear? Cathode ray particle always 1e magnitude, but anode ray particle can be +2 also, +3 also, bhai. Tough to make, but possible to make. Twarga say clear or not clear? Fasak? Done. This bro, He2 plus, this bro, he has a charge of +2e and mass of 4 AMU. This my favorite person, he is called alpha particle. His name is alpha particle. Proton, you know, H plus. Neutron, we say N. Electron, we say E with a negative sign we can represent. This is alpha particle. Done by. Then there is another particle called as beta particle. And when we talk about beta minus particle, beta minus, it is like electron. Mass, charge, whatever, it is like electron. Exactly, we should not say beta minus is electron, but exactly like electron we can say in our syllabus beta particle. And gamma rays is like light, just like light. We call it electromagnetic radiation. Alpha, beta, gamma. In Greek language, ABC is represented by alpha, beta, gamma. Alpha particle clear. Beta particle is like electron. Gamma is light. It does not have any particle, we say. Clear, bhai? Energy packet there, photon there. You will learn in the next class by Planck's quantum theory. But particle in alpha particle is there. Beta particle is particle. We don't say gamma particle. We say gamma rays. So as per old theory, classical mechanics, classical physics, gamma is not having any particle. It is just energy radiation. So alpha particle, beta particle, gamma. Twarga say which is the largest particle? alpha, beta, gamma, largest particle. Alpha. Tarvata, alpha tarvata, smaller than alpha. Out of these three, smaller than alpha, beta. And no particle, as per classical physics, if I say gamma. So tell me, if I want to check this effect, this is a wall. What is this? A wall, an object. And these are the particles. This power of passing the wall is called penetration power. So who will penetrate most easily? Elephant or housefly? Housefly, mosquito, will he be able to cross easily? Or elephant will be able to cross easily? Through a chinna space. Housefly. So out of alpha, beta, gamma, whose penetration will be maximum? Out of alpha, beta and gamma, whose penetration will be maximum? Sir, gamma has no particle, so gamma will be maximum. Beta is chinna particle, alpha pedda particle. So alpha is 1, beta is 100, gamma is 1000. So the penetration power of gamma maximum, beta is 100 times of alpha, gamma 1000 times of alpha, beta 100 times of alpha, and alpha we are taking as our reference as 1. Is this fundamental idea clear, bhai? Whose penetration power is maximum? Twarga say yes. The concept after concept, back to back, we will relate and we will understand. Clear or not clear up to here? Out of alpha, beta, gamma, alpha is the biggest particle. Penetration of the wall will be difficult for him. Beta chinna particle easily can pass through, and gamma is not even a particle, so most easily pass through. Done by? Acha, gamma, EM radiation, it has one more friend also. I will talk about that. But can I go to the next page? Yes? Badhiya. EM spectrum. That is electromagnetic spectrum. So what is the meaning of electromagnetic waves first? Electro plus magnetic, electricity and magnetism together. So understand, if this is your magnetic field, this is your electric field, so this should be the direction of propagation. So if this is the magnetic field, this is the electric field, the wave will move ahead. So if I am the electromagnetic wave, I am moving in this direction, so my electric and my magnetic field and my direction, all three are mutually perpendicular to each other. This kind of a wave is called electromagnetic wave. So wherever there is electricity, corresponding magnetism is also there. You will learn this thing also in physics, moving charges. Have you heard this chapter, moving charges and magnetism? Fleming uncle, left hand rule, something like this, remember? I'm not saying you remember Fleming's left hand rule, but something like this you remember, that some chapter like this exists, so that you will learn in physics. My concern right now is firstly understanding, this will come in second track, first track both. Second track to exactly what I'm telling will come. So here we have magnetic field, electric field and direction of the propagation, direction of movement perpendicular to each other. This kind of a wave is called electromagnetic wave. So let us say this wave is moving like this. What are the properties of the electromagnetic wave? Number one, no medium required. For movement, if you speak something in vacuum, if you go to the outer space and you speak something, the other person cannot listen to you. because sound require medium to travel, but electromagnetic wave does not require any medium to travel. Number one. Number two, speed in vacuum is equals to c. C is the speed of light, and the speed of light in vacuum, c, is 2.9978 something. I will write round off, 3 into 10 to the power 8 meter per second. So the speed of each of these waves in the vacuum is same, 3 into 10 to the power 8 meter per second. Done, bhaiya. For these waves, c, speed of light, is equals to nu into lambda. C equal to nu lambda. C is the speed of light. Nu is called frequency, and the frequency units are hertz, or we can say per second. And lambda is called, I think you all must be knowing this thing, wavelength. Units are meter, angstrom, picometer, etc. Unit of length, wavelength. So C is equals to nu lambda. So for example, if I have a wave here, this is called a crest. Crest means mountain. Trough. Trough means kind of like valley. Trough, crest. So the length between two crests, from here to here, the peak, this length is called wavelength. That's a bookish definition. Bookish definition of wavelength is this. I will give you the definition that you can easily understand. One crest and one trough. This you can consider as one wave, isn't it? One time up, one time down, you can consider as one wave. So this will be called a wavelength. So this also, actual definition is crest to crest or trough to trough. But easier to understand is one up and one down. That complete is called a wavelength. Twarga say, can you imagine the meaning of a wavelength? If there is a wave there, can you find the wavelength if you see ripples in the water? And I ask you to find the first wavelength. So can you see the ripple and take the scale and measure? That is wavelength. What is the definition of frequency? Nu is frequency. Number of waves passing through a point in 1 second. If I talk the frequency in seconds per second, that means frequency in hertz, how many waves have passed through one point in 1 second? For example, in 1 second, 3 waves gone. 1, 2, 3. So frequency will be 3 per second. How many waves are passing through a point in 1 second is called frequency. Understandable? Say bhai. Nu bar, wave number. By name also it is clear. Wave number, number of waves. Number of waves in 1 unit length. Example, 1 meter. If I take 1 meter length, how many waves are in that 1 meter length? That is called wave number. And mathematically, wave number, nu bar, wave number, is just 1 upon lambda. Prati meter, how many waves? For example, this is 1 meter, for instance. And I make like this. So you are having 1 wave, 2 wave, 3 wave, 4 wave. So in 1 meter, how many waves I got? 4. So wave number per meter is 4 waves per meter. See, I don't want you to just mug up the formula, bhai. I want you to feel the meaning of frequency and wave number. Frequency means from a point in 1 second, how many waves passed? wave number is in 1 meter length, how many waves can fit? Say bhai, is the meaning of the 3 frequency, wavelength and wave number clear to you? Done? Now, there are many types of EM radiation, but we have to study only a few. So we have to study from radio waves. So I'm writing like this, radio waves, then microwave. So remember, RAM, radio micro. Or for simplicity, I can write like this, radio wave here, so that the mnemonics can work. Microwave here, RAM, radio wave, microwave. After that, I think you all know VIB-GYOR, rainbow. VIB-GYOR, Vibgyor, rainbow. Towards the Vibgyor, violet, indigo, blue. So write in backward, VIB-GYOR. This is visible region. Now, more than red, infrared. More than red, infrared. Less than violet, ultraviolet. Up to here, any problem? RAM. Then visible. Visible in the middle. Before red, infrared. After violet, ultraviolet. This I am writing the order of wavelength. That's the order of lambda, wavelength. Radio wave maximum, then microwave, then IR, then visible, Vibgyor. In Vibgyor also, red has maximum wavelength. In visible region, red has maximum lambda in visible region, bhai. UV tarvata. Oh, Kittu. फोकस कर ले आंटी. यूवी तरवाता. ओ भैया किटी पार्टी. यूवी तरवाता, एक्सरे, गामा रे. चेक भैया. क्लियर? त्वरगा से भाई. Clear? This is the lambda. What we know C equal to nu lambda. So nu will be C upon lambda. C equal to nu lambda. So nu will be C upon lambda. So nu and lambda are proportional directly or inversely. Nu and lambda are proportional directly or inversely. त्वरगा से directly or inversely? Inversely. That means if lambda is maximum, frequency will be minimum. If lambda will be maximum, frequency will be minimum. Clear hai bhai? So whatever I gave the order here, opposite will be the order for frequency. This is called electromagnetic spectrum. This is EM spectrum. All of them are electromagnetic waves. All of them, all of these are electromagnetic waves arranged on the basis of their wavelength. Say bhai, clear? So do you understand that gamma ray, X-ray behavior will be very similar? Only their wavelength are different. Otherwise, they both are EM rays, electromagnetic waves. Electricity, magnetism, direction of propagation proportional to each other. Only their wavelength are different. Their energies are different. Their speed, their behavior, their penetration power. All these will be same. Do you understand this? Done, bhai? One interesting story I will tell you. One interesting story is कि why this X-ray? They see everywhere they worked. Radio wave used for radios. Microwave, so you also know very well microwave. Infrared, less than red, infrared. Ultraviolet, more than violet. Gamma, they used Greek letter. For X-ray, they just called it X. Let it be X. Why? I'll tell you what happened. देखो भाई, very interesting story, but very small story also. In this experiment, ना भाई, when these electrons strike this metal, listen very carefully. When these electrons are striking this metal, people noticed some energy radiations were coming out of the glass also. Some highly penetrating energy radiations, they were coming out of the glass. How these got generated? This radiation got generated when the electron strike the metal plate, especially heavy metal. When heavy metal, silver, gold, heavy metals were taken, electron strike them. Some radiations came out, which came out of the glass also, and outside some phosphorescent material was kept. That started glowing. Are you getting? By mistake happened. They were doing normal experiment. Electron came, cathode ray came, strike the anode, strike the ZNS coating, glow was coming here, no problem. But then they realized that where the experiment was going on, outside the glass on the table, some phosphorescent material, ZNS was there, it started glowing. So scientists thought that something is coming from this. When electron is striking the metal, something is coming which is penetrating the glass, and outside the glass phosphorescent materials are glowing. So the students asked, sir, what should we name it? Scientists said, because we don't know what is that, let it be X. Are you understood, yaar? By mistake this got discovered and people were not able to understand what the hell is this. By that time EM waves were not famous, or research will be not going on at this level that people can understand this is some electromagnetic wave. Electrons were discovering, yaar, at that moment, 1800s. So scientists said, we don't know what is that. Some rays, some energy there, let's call it X-ray. Are clear hai yaar? So twarga say how the X-rays can be generated. If I want to generate X-ray in the lab, how can I generate the X-ray in the lab? What should collide? Electron should collide with whom? Electron should collide with whom for generating X-ray? Kya baat? Heavy metal. Perfect. Now, before moving ahead, I will once check the NCERT so that you understand up to where we have covered, and then we will move on. Something I will show you basically. Badhiya. So now, number one, these 4 points you will note down in your notebook. These 4 points already we have covered, already I have taught you. Charge to mass ratio of the particle depend on the gas, anode ray they are talking about. Some of the positively charged particle carry a multiple of fundamental unit of charge. This you will note down in your notebook. These 4 points already I have given. Now, can you see this? What have I covered? This all Thomson model and all we will do. I just now covered this green color box. Here it is the story. In 1895 showed that when electrons strike a material in cathode ray tubes, produce rays which can cause fluorescence in the fluorescent material placed outside the cathode ray tube. Since Röntgen did not know this nature of the radiation, he named them, let it be X, and the name is still carried on. Clear hai bhaiya? It was further noticed that X-ray are produced more effectively when electrons strike dense metal anode, heavy metals. Clear hai bhaiya? These are not deflected by the electromagnetic field. Tuck, 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 tuck. High penetration power. Already you know how much high penetration power. You know that also. Sir, penetration power is 1000 times of alpha particle. The gamma rays are high energy radiations like X-ray, are neutral in the nature, do not consist of particles according to classical physics. I already told you. Gamma ray, no particle, according to classical physics. As regards penetrating power, alpha particles are least, you told already, followed by beta, you told already 100 times, gamma 1000 times, NCRT covered. Shall we carry on, bhai? Because sometimes what happened, I did not give that in the notes, I just orally told you. So some people will be very intelligent thinking, oh, sir is telling some GK question. Clear hai bhai? Sir, should we definitely make notes? No, why the notes are required? You are born scientist. You are like supercomputer. Whatever you listen, you always remember. Not required. Whatever you listen, since nursery onwards, you always remember it. I know. Every single detail, everything you properly know, I know. You just came here so that we can get the, what we should say, the pleasure of teaching you people. So no, not required. Notes not required, NCRT not required. Don't practice. Practice is for losers. You're toppers, bro. You don't need practice. Practice needs you. Anyway, moving on. Clear hai bhai up to here? Done bhai? This 12th pass people are asking this kind of a question. It is not funny, it is stupid. Class 12th passed. Have some better doubts. Should I ask you this? Can I teach you without writing on the board? Will it work? Anyway, moving on, bhaiya. This much clear. Next thing. Understand, frequency is proportional inversely to wavelength. That is one thing. Also, according to Planck's quantum theory, we will see very soon. According to Planck's quantum theory is that energy of the photon is hc by lambda, that is h nu. What is E naught here? Energy of one photon, prati photon, one photon only. Energy of one photon is hc by lambda equal to h nu. So energy of the photon is proportional to lambda inversely frequency directly. So that means if I consider this as my basis, I can write one more order here now. What order I can write? The order will be of frequency and energy both. Frequency and energy of the electromagnetic radiations are proportional. Planck uncle told this, we will do this in the next class in numericals also. But according to this, we can also write frequency and E naught order, that radio wave, here maximum, here minimum, then microwave, then IR, then red, orange, yellow, green, blue, indigo, violet, then UV, then X-ray and gamma ray. So who has the maximum energy? So this gamma ray has maximum energy, maximum frequency, but minimum wavelength. Radio wave have maximum wavelength, minimum frequency and minimum energy. Say bhai, this much can you understand? This much can you understand? Say bhaiya. Done? Shall I move on? Shall we move on? So everything regarding this experiment is done. Cathode ray, anode ray experiment, penetration power, green color boxes, everything covered. Can we now move on to the atomic models? We will come back to Planck's theory in detail, but firstly, can we now move on to a little easier topic, atomic models. In atomic model, the first model we are going to study is the Thomson's model. Thomson's model is very simple model, plum pudding model, watermelon model we can call it. So the model is like this. He said that atom is like a sphere. Done by the shape of the atom is sphere. Positively charged sphere. So positive charge and mass is evenly distributed. According to Thomson uncle, the positive charge and the mass, even all charge and all mass, are evenly distributed inside the atom according to Thomson model, which is wrong. We will prove it. But this is what Thomson said. Electrons, which are negatively charged particle, they are embedded. Electrons are embedded inside this solid sphere. So this was the Thomson's model. He said atom is round. He also said one more thing. He said that diameter of atom is of the order 10 to the power minus 10 meter. That is 1 angstrom. So according to Thomson, the diameter of the atom was in the order of 1 angstrom, which interestingly was same thing which Rutherford also found. Rutherford found this only, that diameter of atom is in the order of 1 angstrom or order of angstrom. Maybe 1 angstrom, 2 angstrom, but order of angstrom. Clear, bhaiya? Electrons are embedded in this sphere. They are scattered. So charge and mass is evenly distributed. What are the good points from the Thomson model? It explained, or it stated electrical neutrality of atom. So he said that atom will be electrically neutral, plus and minus will be equal. Clear, bhai? Plus and minus will be equal. That is what Thomson have said. He said that plus and minus is going to be equal. Clear, bhai, up to here? It stated the electrical neutrality. But one thing he said wrong. What he said wrong? That all the charge and mass will be evenly distributed. Can I go to the next page? This is class 9th topic. In junior inter also there, but in 9th also there. This much low level when we are going, we should not invest too much time on it. Moving on. Then came alpha particle scattering experiment. So alpha particle scattering experiment came. Alpha particle scattering experiment. So what was done? A thin sheet, a very thin sheet of gold was taken. Around 100 nanometer thin gold sheet. Around 100 nanometer thin gold sheet was taken. On that, remember alpha particle? Alpha particle, remember helium 2 plus. Alpha particle was bombarded. Alpha particle was bombarded on a thin gold foil, and alpha particle, just for your memory, let me remind you, alpha particle is helium 2 plus. He has a 2e charge and he has 4 AMU mass. So alpha particle is having 2e charge, 4 AMU mass. Now I want you to focus. Proton has 1 AMU mass. Charge 1e. Alpha particle have double charge and 4 times mass. So can I say my alpha particle is like elephant of particles? Can I say? Can I say that my alpha particle is like elephant of particles? 4 times mass, double charge as compared to proton, as compared to subatomic particle. So he's like elephant of particle. Now tell me, if you are humans, elephant is coming towards you and you are scattered. According to Thomson said na, mass and charge are evenly distributed. If Thomson is correct, and if you are scattered in a field and elephant is running towards you, so will the elephant be able to cross you, or will it strike you and bounce back? What would happen in the real life? That much brain, though, I think you should be having. Many humans, hundreds of humans are scattered in a field. Elephant was running towards them. Will the elephant be able to cross over, or will the elephant be bounced back by 180-degree angle, or obviously cross over? This was the expectation. Expectation was alpha particle will pass through. Little deflection, because when elephant will go over you, so little bit deflection will happen. Exactly straight he cannot go, but bouncing back or large deflection though not possible. It will be able to cross. This was expectation. So what they did, they placed at the back a fluorescent coating. As a detector. And surprising result came, bhai. I will tell you what was the observation, and then I will tell you what was Rutherford's conclusion. So number one, his observation was 99%. He found that 99% alpha particles passed undeflected. Sir, what do you mean? I mean, most of the alpha particles, they passed straight as if no one was there in the field. Most of the alpha particle passed straight without any deflection, as if this foil was not there. So what Rutherford understood? Acha, 99% chinna deflection le do, no deflection. That means 99% of the space in an atom is empty. This much brain are you able to apply or not? Yeah. Arey bhai, elephant were there. We understand. It will cross. We understand. But crossing as if nothing is there. That means nothing is there. So 99% space in an atom is empty. First point, observation and conclusion clear. Conceptually understanding how the model was constructed, how Rutherford observed the experimental information and created conclusion. This is what you have to learn. Sometimes people ask this also. Ki sir, if Thomson model is wrong, Rutherford model is wrong, Bohr model is partially correct, then why don't we directly read the quantum mechanical model? Bhai, quantum mechanical model also, whatever is there in NCERT, that much to people have found, na? So you are history student or science student? Are you history student or science student here? Sir, science, sir. Then why are you reading the model quantum mechanical also? Why don't you create your own model? And when you create your own model, you will do experiments like this only. But how would you know how the experiments were done before? Two things. Number one, how the scientists think. And once you understand, sir, this too I can also think, then you will understand that scientists are not from other planet. They are people like you and me only. They just had more confidence. Number one. Number two, you will understand that whatever discoveries are already made, by mistake, don't discover the same thing. So it is teaching you the analytical way, how the observational physics works. Rutherford model teaches you how the observational physics works at a very simple level. Ki bhai 99% pass straight as if nothing was there. So conclusion, nothing is there. Am I clear, bhai? Understood, bhai? If by mistake any junior inter IQ came in the long term and have this kind of doubt, I think clear. Moving on. Then what he found? He found that some of the alpha particle, they got scattered by Chinna angles. This was expected. Some got deflected. Some got deflected by small angles. This was normal. This was expected. This is exactly what we thought would happen. We thought this only would happen, na? Elephant will be running towards you. He will climb over you. Little deflection. So some of the alpha particle got deflected by small angles. Nothing. Chinna. Means okay observation. Expected observation. Problem was this. Bhai. This bhai sahab. This alpha particle. He went straight. Imagine I am elephant. Sir, you are looking like elephant only. Oye, I am on dieting now. Imagine I am elephant, highly fit elephant with six-pack abs. That elephant is running towards you. And the elephant came towards you. You did this. And I bounced back by 180-degree angle. Possible kya? Is it Telugu movie kya? Ki hero will come, will hit the ground, rod will bounce, hit the villain, villain will fly, hit the jeep, jeep will rotate. Real life hai bhai. In real life, a particle as heavy as alpha particle cannot be kicked by proton or neutron. Proton is 1 AMU. How can a 1 AMU person collide with 4 AMU person and 4 AMU person went back? So bhai, 1 in 20,000 particle, very less, bounced back with large angles. Large angles means even 180 degree also bhaiya. 180 degree means zui zui. Elephant came and went back. अरे से भाई क्लियर है? अरे क्लियर है भाई? तो 1 in 20,000 are bouncing back. By this Rutherford got the idea, and for this idea bhaiya, he should get all the praises in the world because he gave us the idea about nucleus. Then bhai, so what idea he got? He got that all positive charge and most of the mass is concentrated. It is not scattered. Opposite of scattered is opposite of scattered, concentrated. All the positive charge, most of the mass is concentrated in a chinna space, in a small space called as nucleus. So which scientist was the first one who gave you the idea about existence of nucleus in the atom? Rutherford. So Rutherford said, he said, कि elephant came, alpha particle, bounced back by 180 degree. It is only possible, it is not possible by one proton or one neutron. It is only possible if all proton and neutron come together, come very, very close in a very small space called as nucleus, which is now 100 times heavy. Because 100 people combined. Now alpha particle will come, it will be bounced back. Say bhai, clear? Observation and conclusions, clear or not clear? So all positive charge and mass, most of the mass, is concentrated in a small space called as nucleus. This was the idea of Rutherford. One more very interesting thing he has done. What he did, he calculated diameter of atom at 10 to the power minus 10 meter order and nucleus at 10 to the power minus 15 meter order. He said atom diameter he gave almost same as Thomson. कि around 1 angstrom, 2 angstrom, in some angstrom only the atom radius will be there, but the nucleus will be 10 power minus 15 meter. NCERT says कि this size is so much, you can understand कि if cricket ball is the nucleus, then 5 kilometer big circle of radius 5 kilometer you will make, that much big is the atom. So in a 5 kilometer city, 1 cricket ball is the nucleus. You can understand how much space is empty. Imagine a city of 5 kilometer length, 5 kilometer breadth here like this. In the middle, only 1 cricket ball there, remaining city is empty. That much empty is the atom, almost. Clear hai bhai? This thing will come in physics probably. Means when we studied in physics, it used to be there. It used to be called as distance of closest approach. Up to 2 years back also I remember it is there. Now syllabus change happened in physics, so I am not very sure it is there in physics still or not. Hopefully it is there. You will learn that how it is found by using electrostatics. But even if not there, NCERT of chemistry mention only this much. Easy, but it consumes time, and our time should be only dedicated to our syllabus. Anything beyond the syllabus, if I teach you, it will be wasting your time, and I will not get time to properly explain the things from NCERT. Every detail, every green box, every line should be clear, bhai. So for that, I don't want to cross the boundary of syllabus. Say, bhaiya, clear up to here or not? Rutherford's alpha particle scattering experiment observations and conclusions clear. Can I go to next page? Great. Now, second model is Rutherford model. Now, Rutherford's atomic model we are discussing. What the Rutherford said? He said, proton and neutron are present in the nucleus. He said this is nucleus, and nucleus contain proton and neutron both. He said electrons are revolving around the nucleus. Electrons are revolving around the nucleus in concentric circles. This was the Rutherford model, and this model was shamelessly copied from solar system. Done, bhaiya? So just like sun in the middle of the solar system, planets are revolving around it. Rutherford also thought, good idea. Nucleus in the middle, electrons are revolving around it. Say bhai, up to here any problem, any samasya, any pida? Drawback of this model I will teach you in the end of the class. Now, before entering into the drawback of this model, we have to see a very small thing. Representation of an atom. In this manner we represent here. This is how the atom or ions are represented. Kinda Z. Z is atomic number. Z is atomic number. X is the symbol of the atom we use. A is the mass number. Mass number is neutron plus proton. Atomic number is only proton. Atomic number proton, mass number neutron plus proton. Charge can be +2, -2, +1, -1, etc. So if someone asks you number of proton, it is Z. Number of neutron, it is A minus Z, and number of electron will be Z minus charge. For example, if I write 16s32 2 minus, 16s32 2 minus, it is sulfide ion, and if I ask you find the number of electrons in this, so number of electrons will be Z minus charge. How much is the atomic number? Sir, Z is 16. Minus charge. Sir, charge is 2 minus. So 16 minus charge, 16 minus minus 2, minus minus plus, 16 plus 2, 18 electrons are there. Number of neutrons. Number of neutrons are A minus Z. Number of neutrons are A minus Z. Paina minus kinda. 32 minus 16. So 16 neutrons. And number of protons is equals to just Z, which is 16. So 16 protons. Say bhai, is this question clear? This also used to be the level of NEET examination once upon a time. 2020 or 21, even this question came, they gave some element, here 237, here 144, find the number of proton, neutron and electron. This also used to be the level of NEET examination. That's why the cutoff was 600, 580, 590 type of. Clear hai bhai? Some questions still can come. Out of 45 questions, 5-6 questions still can be easy. That also we should be prepared for. Hanji bhaiya, shall we do some examples now? Can we do some examples fast? This is NCERT solved example. In NCERT solved example, they mentioned that a species have 18 electrons, 16 protons, and mass number 32. Write the symbol, and symbol was that. Solved example. That you will solve obviously in the evening. I'll give that homework. Question is, find number of neutrons in 6C13 and 7N14. Tell bhai, in both of them how many neutrons are there? Twarga find. Neutron is A minus Z. Paina minus kinda. Correct sign. So number of neutrons here came A minus Z. 13 minus 6, 7. Here number of neutrons are 14 minus 7, 7. So number of neutrons are equal neutrons. The two species are called isotones. Isotones means equal neutron. Say bhai, clear or not clear? Finding neutrons, okay. Also understood the meaning of isotones. Equal neutrons of two different elements. Isotones. Chali, find number of neutrons in 1H1, 1D2, 1T3, 6C12, 6C13, 6C14. For all of them, find the number of neutrons by. For all of them, find the number of neutrons. 17Cl35 and 17Cl37. So, sir, number of neutrons here 1 minus 1, 0. Here 2 minus 1, 1. Here 3 minus 1, 2. For these three people, answer is 0, 1, 2. Now, for these three people, let's find the number of neutrons. So, the number of neutrons are 12 minus 6, 6. 13 minus 6, 7. 14 minus 6, 8. For these two, number of neutrons are 35 minus 17, 18. And 37 minus 17, so 20. Say bhai, everyone is comfortable in finding number of neutrons now? Everyone comfortable in finding the number of neutrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 examples done bhai. How many you need now? Now, same Z, same atomic number and different mass number. Same atomic number, different mass number. Tuck, tuck, tuck. Only 12, 13, 14 different. Same atomic number and different mass number. So same atomic number and different mass numbers, they are called isotopes. Clear bhai? Same atomic number, different mass numbers are called isotopes. One very important note bhai, chemical properties majorly depend upon electronic arrangement. Very important question bhai. So chemical property depends upon the electronic arrangement. For example, if I am a metal, I want to become positive, I have to release electron. I want to take electron, I will become negative. So reaction happens by giving and taking electron. So electronic arrangement, chemical property depends upon electrons majorly, electronic arrangement. But for isotopes, only neutrons are different. Say bhai, check all the example. Atomic number same, number of neutrons are different, neutrons are different, neutrons are different. Electron and proton are same. So for isotopes, only neutrons are different. So their physical properties are same. So say bhai, this understood or not understood? Chemical property depend upon electronic arrangement. Isotopes have same proton, same electron number, only neutron different. Isotopes have only neutron different. And neutron does not play much role in the chemical reaction. You can assume neutron plays no role in the chemical reaction in your syllabus. So isotopes will have same chemical physical writing mistake, same chemical properties. No one said also anything. You are mugging up this only kya? Same chemical properties. Physical property is obviously different, like mass, 1 AMU, 2 AMU, 3 AMU. Physical property different. Physical property different for isotopes. Example, mass. But chemical reaction same. If hydrogen react to become H plus, deuterium also react to become D plus. Tritium also react to become T plus. If carbon form covalent compounds majorly, carbon 12, 13, 14, everyone will form. Say bhaiya, clear or not clear? So isotopes have same chemical property or different chemical property? Isotopes have same chemical property or different chemical property bhai? Isotopes have same chemical property or different chemical property bhaiya? Same. Why? Why? Because chemical property does not depend upon number of neutrons. And isotopes have same number of proton. All the three have same number of electrons. Neutron only different, which have no major role in the chemical property. Say bhai, clear or not clear? Faizun, clear? Faizun, clear? Then same mass number and different atomic number. Understand what is same? Mass. Twarga type and send. What is mass called in Telugu? What is mass called in Telugu? Mass in Telugu. Bilkul. Clear bhai? Baruvu. From there the word bar came. Isobaru. Isobar. Example 6C14 and 7N14. Their mass number is same. So these two are called isobaru. Isobar. Easy. Twarga say bhai, up to here. Anyone have any problem? 30 seconds I am giving you. Twarga say. Anyone have any problem up to here? Done bhai? Badhiya. Now as per the NEET syllabus, only isobar and isotopes are in your syllabus. So if you feel like, sir, I remember isosters also, isodifers also, not required. Okay, bhai? Not required. Don't waste energy and time on something which is not there in the syllabus. Clear? If you want to listen, I can tell you isodifers. You can, like, how you can remember if you want. I'm not giving in the notes. It just 2-3 seconds I will tell. Diaper, isodiaper. So what will come out of the diaper? Extra. Whatever the diaper cannot absorb, that will come out of diaper. So those who have isodiaper, same amount of extra. So what extra? Neutron extra. So if N minus P, neutron minus proton, if the number of neutron are 10 more than proton in two species, for example, they both will be isodifers. Number of neutron excess is same. But that has more to do with, it has nothing to do with chemistry. It has more to do with nuclear physics. That is why not in the syllabus in chemistry. Clear, bhai? It has more to do about, it's more required for nuclear physics, radioactivity and all. Clear? So don't worry about the things which are not in the syllabus. Know your syllabus well. Shall we move on, bhaiya? Coming to the last part of the lecture, as I said, I will tell you the drawback of, I said na, drawbacks of Rutherford model. I said I will tell at the last. So now here we are. Drawbacks of Rutherford's model. Number one, simple drawback. No proper explanation of electronic arrangement. So Rutherford has no idea about how the electrons are arranged around the nucleus. Sir, what do you mean? Achha, you tell me. This must be, you can also tell. If this is the nucleus, this is shell number 1, shell number 2. How many electrons will be there in the first shell maximum? In first shell maximum, how many electrons can come? First, we are winding up. How many electrons can come in the first shell? 2. How do you know? So someone taught us. Why they taught? Because some scientists have found this. And that was not Rutherford. That was Bohr. Isn't it? How many electrons will come in the shell? How many shells will be there? Nothing about that Rutherford said. Rutherford said only one thing. Nucleus in the middle, electron around it in concentric circle. Bhai, how many circle? Bhai, how many electrons prati circle? He did not give any explanation for it. First drawback, clear or not clear? Like, you know, there are 2 electrons in the first shell that Rutherford did not tell. Is this clear, bhai? Drawback number 1. Drawback number 2. Accelerated charged particle emit radiation, energy. This also you might have studied in physics also last year. Also, I just now said, little bit I said. But in physics, you might have read moving charges. Moving charges. When the charges are accelerated charged particle, they release some radiation, mostly electromagnetic radiation. We can call it EM radiation, like X-ray, gamma ray, something. Accelerated charged particle emit radiation or energy. Clear, bhai? This was given by Maxwell. This is Maxwell's theory. So, electron must emit energy and eventually must fall, in English it is called spiral, inside nucleus within 10 to the power minus 8 seconds. Understand the story. When a charged particle is accelerated, it releases energy. That was Maxwell's theory, moving charges and magnetism. You will read this thing also in detail. Problem that came was, this bhai sahab got inspiration from, or in other words, he copied the theory from solar system. But one mistake he did. In solar system, the planets are not charged. But in atom, the electron was charged. And if charged particles are accelerating, circular motion always have change of direction. In circular motion, you always change your direction while moving. Otherwise, you will move in a straight line. Circular motion means direction always changes. So velocity will always be changing, and changing velocity means acceleration there. So when electron is in a circular motion, it is accelerated. An accelerated electron, charged particle, planet, no charge. No extra energy released from anywhere. But electron charged. And when moving charge, accelerating charge is there, it releases energy. So people said, ki bro, Rutherford bro, one chinna thing you explain us, ki if your electron is charged, if your nucleus is positive, electron is revolving around it, it is charged. So while revolving, his energy will slowly decrease. Because accelerated charged particle release energy. So electron will release energy. His energy will decrease. And when energy decrease, then this minus and plus will attract each other and the electron will fall inside. Like a spiral. And all this, as per the mathematical calculations done by some scientists, all this should have happened within 10 to the power minus 8 seconds. Not even 1 second. Not even millisecond, not even microsecond, even lesser than that. Hello? So that means you should have blasted by this time. If Rutherford is able to explain the atom properly, then by this time the electron should have gone inside the nucleus of your body only. Every atom by this time in your body should have blasted. But because you and me, we are alive. Camera also right now is not blasting. TV not blasting. That means Rutherford model cannot explain stability of atom. Isn't it? Obviously, atom is not blasting. That means the model is incomplete. Something is missing in the model. Twarga se up to here in the story, any problem, any samasya, any pida. Done. Up to page number 40 of NCERT, we have covered everything. Up to page number 40. We can take the screenshot of this. Already on YouTube, I have posted the screenshot, you'll be able to get. I'll show you up to where we have done. And if you want to read, and you should read, especially those who want to get top ranks in future, develop the habit of reading in your free time. Done, bhai? So all this already covered, this all covered. Isotopes, isobar covered. This is the thing I mentioned. Lastly, an important point to mention regarding isotopes is that chemical property of an atom are controlled by the number of electrons, which are determined by the number of protons in the nucleus. Number of neutrons present in the nucleus have very little effect on the chemical property of an element. Therefore, all isotopes of a given element show same chemical behavior. This was NEET 2021 question also. Then, these are the homework you will do, 2.1 and 2.2. These two solved example are the homework. Then, drawbacks of Rutherford model, this I told you. Then, no, up to 36 only we have done. Up to page number 36. Here, even though I have told, but complete details I have not told. Like few things I have told you already. Ki this oscillating electromagnetic field are perpendicular to each other. Unlike sound wave, they can travel in the vacuum also. Electromagnetic spectrum is there. This spectrum I told you, radio wave, microwave, IR, visible, UV, X-ray, gamma ray. But I have to tell this in more detail. So I will not say up to page number 40, but take up to page number 36 we have done. So up to there read. Up to page number 36, read every line properly. Up to page number 40 is our weekend syllabus. Up to this page is our weekend syllabus. Done, bhaiya? Sir, don't mind asking this. I heard that online students have to attend offline classes at some point. If that is true, during which time period do they have to attend offline? No, online we will run till the NEET examination, online batch. ठीक है भाई. But very clearly I'm telling you, even though we are running online batch, the result that is generated from offline is far better, 1,000 times better than the online, because of a simple reason. No one is there in your house to monitor you, and you know yourself very well. Without monitoring for 9.5 months, impossible. 9.5 days also you will not study broadly. Done, bhai. Weekend syllabus in the group, I think today either they would have posted or they will post it by today at any cost. ठीक है भाई, or maybe they would have posted already. Done, bhai. So in the new group you can check once, but they will post. Impossible that they will not post. Clear है भाई? चलिए, done. Up to here it is clear, bhai. Up to what we have done. So every single line of NCERT, every single theory which is required, we have covered. Next class will be numerical. And that will be the end of your weekend syllabus. Done? Chali then, tata, bye-bye, read well, revise well, have high ambitions and work to achieve it. Everything should be clear to you. Everything should be remembered by you. Good marks will come. Every week, every day you take care of, NEET will take care of itself. Bhai. You will not have to worry about the level of papers and all. Chali then, tata, bye-bye.